Hey guys, this is test 42 game 2. This is the loading dock game. It's an ordering game. We know this because the bays are numbered 1 to 6 and the rules are all regarding higher number, lower number, that sort of thing. So we're basically placing these variables F, G, L, M, P, T in order from 1 to 6. Now the rules are for the most part relational, just saying one thing is higher than another. So for that reason, although I've drawn these 6 spaces right here, I'm actually going to lay out the rules to the side. So the first rule tells us that G is a higher number than L, giving us the general ordering L-G. The next rule says L is higher than T, so we've got T-L. I automatically link those things together. Next, we've got P is higher than F. We don't have either of those variables here, so I'll skip that rule and come back to it when we have more information from the later rule in the hopes that we'll be able to link these together. And the next rule does let us do that. It tells us that T and P are next to each other. So that tells us we've got either PT or TP occurring consecutively. So I'm just going to box those guys. We know that we don't know which one exactly comes first, but we do know that it's either PT or TP. And then we go back to the previous rule, P is higher than F. So that gives us F dash P. So we've got F is before the PT, TP box, before L, before G. And this is our initial setup for the game. I would not bother doing mapping out a bunch of little restrictions like G can't be 1, 2, 3, 4, or F can't be 6, 5, 4, 3. It just isn't worth all that effort. But anyway, this is our initial setup for the game. I've also laid out the variable m here just because m is the only variable about which we don't have any rules at all. So m could go anywhere. M could go 1, m could go 2 if it's after f. It could go after the TPPT box. It could go between L and G, or even after G. So m is the most flexible, loose variable about which there are no rules at all. So a lot of the game is going to revolve around the placement of m, and then whether it's PT or TP, but that's a little bit more defined. M is completely open-ended. Anyway, number 6 is a partial orientation question. They're talking only about the first 3 bays. Now, we know that the first 3 bays will have to include F, because F is either 1 or 2. It's 1 if M goes after it, it's 2 if M goes before it. So F must be included in our choices, in our correct answer choice. So any choice not mentioning F is automatically gone. This gets rid of choice E. Now, we also know that our correct answer choice will mention at least one of P or T, because if M was 1, F would be 2, then one of T or P would go third. And if M was second, again one of P or T would go third, and if M was after them, one of P or T would go second. So every correct answer choice must include at least one of T or P, and if you scan through the choices, you find that neither B nor C mentions either of those. So for that reason, B and C are both gone. We're down to A and D. Now, D is unacceptable because we can't have T before F. We have to have F before T. So D is gone, leaving A as our answer to number 6. Next, number 7, what variable cannot go on 4? So this really depends upon the placement of M, right? Because if M goes after most of the people, most of the things, then L would go on 4. So of course L is eliminated off the bat. We also know that if M goes earlier than this whole thing, we're going to have T or P on 4. So for that reason, D and E are eliminated. Now there's still a lot of ambiguity here. What we do know is that F could never go on 4 because it has to have at least 4 things after it. So F could never be 3, 4, 5, or 6. F's latest placement could be on 2. We also know that G could never be on 4 because it has to have at least 1, 2, 3, 4 things before it. So G's earliest placement could be on 5. So the answer to this question has to be F or G. F is not a choice, but G is. So G's our answer choice A. Now C, M is not our answer, of course, because M could really go anywhere. M could go in just about any of the places, pretty much. So for that reason, we could have F, T or P, and then M. So for that reason, M is also a could, and it's eliminated. The one place M could not go would be on 3. because of the TPPT box. Either if we have M before it, it would be right before it would be on 2. If we had M right after, it would be on 4. But it could never be on 3, but that's not what they're asking here. Next, number 8, if we have exactly one thing between M and G. So that gives us two possible layouts. Either we have G space M occurring consecutively with the one thing between them, or we have M space G with exactly one thing occurring between them. Now, G space M is not possible. I mean, if you added it on to the end of our sequence right here, what would go there? There's no other variable that could potentially go in that space right there. Everyone else is in this order. We'd have F, T or P, L, G, something M. But what would that something be? There is no something. So for that reason, G space M is impossible, and we eliminate that possibility. We're looking at M space G. So if we have M space G, what's going to go in there? Well, it would be L. We're going to have M kind of right here. F on 1, TPPT on 2 and 3, M on 4, L on 5, G on 6. That's the possible ordering that we have. So now they're asking us how many are fully determined. Well, there's F, and then there's M, L, and G. We don't know whether it's PT or TP, but these four, F, M, L, G, are fully defined. That's 4 things. So our answer to number 8 is C. Next, number 9, where could L go? So L would be on 4 if M goes after it. M would be on 5 if M goes before it. So the answer to this question is either 4 or 5. 4 is not a choice, but 5 is. So D is our answer to number 9. Next, number 10, general must be false question. So 4 of these choices could be true. We eliminate those 4, and whatever remains will be our answer. So we just run through the choices looking for what could happen and eliminate it. Could F and M touch? Yeah, if M was on 2 or if M was on 1. Either way, they could touch. A is gone. Next, G is, we also saw it in question 6, number choice A, by the way. We saw F and M touching there. Next, could G and M touch? Yeah, if M was 5 or 6, those could touch. So B's gone. Could L and F ever touch? No, of course not, because T and P are in between in either order. So for that reason, C is impossible and is our answer. I will go through the rest, though. Could P and L touch? Yeah, if we had T, P, L, that could work. So for that reason, D could happen. And then E, could T and F touch? Yeah, if we had F, T, P on 1, 2, and 3, or on, M on 1, F on 2, T, P on 3, 4, that could work too. E's gone, leaving C if you didn't get it before. Next, number 11, if P and L touched. So that would happen if we had TPL. So I'll lay that out right here. Then they're asking us, what could be true except. So of course, if we have TPL, we're going to have G following, we're going to have F coming before, and M is basically floating around. It could be anywhere here, but TPL is a consecutive box. So it could be true except, could F be on 2? Yeah, if M was on 1, F could be on 2. So A is gone. Could P be on 4? Yeah, if M was on either 1 or 3, with F on either side, we could have F, M, T, P, or M, F, T, P. Either way, P could be on 4, so B's gone. Could T be on 4? That could never work, because we can only have F and M before it. That's only 2 things before it. So T's earliest point would be 3, not 4, so C is impossible and is our answer to number 11. I will look at the rest, though. Could G be on 5? Yeah, we could have F, T, P, L, G, and then M on 6. That could work, so D's gone. And then could M be on 5? Yeah, if M was between L and G, we could have F, T, P, L, M, then G on 6. That could work, so E's gone, leaving C if you didn't get it before. Next, number 12, if P's on 4, how many are determined? So, of course, if P's on 4, I'll draw that on the top diagram right here. If P's on 4, we'd have to have M and F before it, and the M coming earlier, and then we'd have to have the TP ordering in order to put P on 4. So P's on 4, T's on 3, we have L on 5, G on 6 coming afterwards, but the placement of M and F is not fully determined. We could have M on 1 and F on 2, or we could have F on 1 and M on 2. Either of those is possible. So T, P, L, and G are fully determined, but M and F are not. So there are 4 things fully determined. So for that reason, C is our answer to number 12.